Hello students, welcome back to the another session of our artificial intelligence. In this video, we are going to learn iterative deepening depth first search algorithm. So this we can think about it is a one type of uninformed or blind search algorithm used by the agent in artificial intelligence. The agent can be a problem solving agent or it can be a goal based agent. As we know, the searching algorithm we classify into two types, informed and uninformed. So this algorithm is comes under the uninformed algorithm, means there is no information is given except how to traverse. So only the information is provided, that is how to traverse. It is a combination of depth first search as well as the breadth first search. So what is a depth first search? What is a breadth first search? I have already covered in my previous video. So in description section, I also put the link so that you can refer it. So it is a combination of both breadth first search as well as the depth first search, means all the problems arise in previous case is solved here. So in this case, what happened? The here searching process is combination of number of iteration. Each and every iteration, the depth limit is increased by 1. So what happened? It is a combination of depth, means depth is determined by the depth first search, and each and every iteration, the depth limit is increased by 1, as well as all the element of the same label is traversed. That's why it is a combination of both the DFS as well as BFS. So when we have to use this algorithm, when we have searching space is more, means there is no limit for the searching space. At that time, we should go for the algorithm. This type of searching algorithm, we should go for it. Let us understand how the algorithm perform its operation. So it calls fast the depth first for the different depth starting from the initial value. At each every iteration, what happened? The depth first search is restricted from going beyond the depth, means whatever depth is given after that we cannot able to go. Hence, it performs the depth first search in breadth first search fashion. Let us understand. So first, we have to know what is our goal node. So let us understand what is a goal node. For example, in this case, our goal node is F. So our goal node is the F. So now depth, we have to start from first iteration. So this is our iteration 1, depth is 0. So this is our depth. So here depth is 0 because depth is the number of pages from the root node. Here A is the root node and there is no edges. That's why the depth equal to 0. And what are the traverse node? First node is the A. So we check whether A is goal node or not. No, we are not reached the goal node. Then what happened? The second iteration, the depth is increased by 1. So now the depth is 1. So here we have to traverse. So from after searching, we will go to the B. So in case of depth 1, B, then we search C. B is not equal to F, C is not equal to F. Means we did not get the goal node. Then third iteration means depth is 2. So this is depth means from for this node, depth is number of edges from root node. So this is the root node 1, 2. So that's why the depth is 2. So this is depth 1, this is depth 2. So here what happened? This is a combination of DFS as well as the BFS. So DFS means depth is 2. BFS means we have to traverse the node by level wise. That's why it is combination of depth first search as well as the breadth first search. Depth means we have the depth limit up to 2 we have to traverse. Breadth first means each and every level node we have to traverse. That's why it is a combination of both DFS as well as BFS. So here what happened? What are the nodes we have to traverse? A, B, C we are already traversed. A, B, then C, then we will search D. D is not equal to goal node. Again, we have to go to the next node E. It is not a goal node. Then we will go to the F. Here we got the goal node. So here we have to stop. After that, the no iteration will be performed. We will got the result. So this is the way the searching algorithm perform its operation. Let us take another example. For example, this is our goal node is different goal node. Then according to that, we have to search the operation. For example, our goal node is the P. For example, goal node is the P. So first iteration, what is the depth? Depth is 0. So what are the node we traverse? That is the A. Then second iteration, the depth is increased by 1. So here the depth limit is that is the 1. So what are the nodes it will be traversed? A, B, C. Our searching element is P. Till now we are not reached. Then iteration is increased by 1 and depth also increased by 1 value. So here what happened? Depth is 2. Now in this case what happened? A, B, C as it is now this line we have to traverse. First D we will check with the P. No. Then we will check E. No, it is not a goal node. Then we will traverse F. It is not a goal node. Then G. It is not a goal node. Then next iteration. What happened? The depth is increased by 1. Each and every iteration, the depth is increased by 1. Now, it is same as the previous. All the things we have to traverse. Then what happened? Now, this is the depth 3. So now first element we will search, that is G. Sorry, H. H which compare with the P value. No, it is not equal to the goal node. Then P. P is not equal to, yes, it is equal to. So what happened here? We got the result. So now the agent know the path to reach the goal node. So what is the path? A to B, B to C, C to D, D to E, E to F, F to G, G to H, H to P. So this is the path the agent has to traverse to reach the goal node. So this is the way the problem solving agent or the goal based agent use the iterative deepening depth first search algorithm. Iterative means each and every iteration the depth is increased by 1 and searching element is done by the label wise. That's why it is called as the combination of the depth first search as well as the breadth first search. Time complexity of this algorithm is the order of b to the power d, where b is the branching factor of searching tree as well as the d is the depth of the tree. And the space complexity is the order of b into d, multiplication of the branching factor with the depth. Optimality of this algorithm is that if it is optimal if the past course is non-decreasing function of the depth of node, then it is a optimal. We will definitely got the optimal solution from this algorithm. Next one is the completeness of this algorithm. If there is a solution is exists, then this search algorithm is definitely guaranteed to find the solution or get the goal node if the searching tree is finite. If it is infinite, then it is very difficult. But two conditions is required. First one is that if the solution is present as well as the search tree is the finite, then this algorithm definitely give us the solution. That's why it is complete. So next we have to understand what are the advantage of this algorithm. This algorithm can be used for the graph as well as for the tree because it is a generic algorithm which can work in any searching space. That's why it can be used for the both graph as well as the tree. So here another advantage, it is memory efficient. Why? Because it stores the nodes only up to the current depth limit instead of storing the all the nodes. Means here we have to increase each and every iteration the depth, and according to that we are going to store the node information. We are not going to store all the node information of the tree. That's why, or graph, that's why it is memory efficient, means it required less memory. As up to the level where the goal node is present, only up to that level we are going to store the node information. Beyond that, we are not going to store. That's why it is memory efficient. It is comprehensively that ensure a solution will be found if there exists. So in this case, what happened? If there is a solution, it will definitely give us the solution. So it is both, it is a complete as well as it's the optimal. So in this case, what happened? Each and every iteration, we are increasing the depth. So there is no chances of it will go to the infinity loop like the depth first search algorithm. It has also some disadvantage. Visiting certain nodes is more than once might slow down the searching process. Here there is a chances that we are visiting the same node multiple times if it is present in the tree. At the time, searching process is very slow. Here what happened? Regressive recursion is needed to perform its operation. So this is all about the iterative deepening depth first search algorithm. Hope you are able to understand the concept details. Thanks for watching the video. Please subscribe the channel, like the channel, share the channel. Thank you so much.